Well, guys, I'm back with another vintage piece of test equipment. This is the second of three pieces of vintage test equipment I bought from a gentleman not too far away from me. And I originally went there chasing the Hickok transistor checker that I just did a video on. And one of the items that he had there that he had been advertising, I think he started this thing at like 50 bucks. And there was no traction on it, no interest in it. And well, again, that's on Facebook. Might not be the best market for something like this. But when I went out there to pick up the transistor checker, I noticed he still had this. And I think I offered him like 5 or 10 bucks for it, and he decided to take my offer. And I took it just because I thought it was kind of a neat novelty. And the other main reason I took it was because regardless of what I decide to do with this thing, there are 3 tubes right here. There are 3 vacuum tubes right here, which are the type that actually have little screens inside that light up when energized correctly to display digits. So I don't know whether or not these are technically Nixie tubes. Nixie, I believe, is what the spelling is for that. You can look those up if you want. A lot of people make interesting projects out of those, like clocks and counters and things like that, because they're just kind of cool looking when they're lit up. But a lot of them have the numbers are actually facing up, so you would actually be looking at the top of the tube. You would be seeing 3 circles, as opposed to here you have 3 tubes that are actually standing up, so you're actually looking at the sides of the tube. The tops of the tubes are facing up. There is a piece missing right here, which is basically just a piece of plastic and a little bezel, I think, that went around this that actually dresses this up, and these would shine through the plastic and look a little bit more professional, obviously. And I don't know why somebody had this apart. This thing might be complete junk. You know, I haven't let the smoke genies out. I wanted to leave that as a surprise for all of us to see what would happen. Here's the power switch, apparently is just kind of floating in here. So I'm going to have to make sure that that doesn't catch anything. But what this is this is another Hickok piece of test equipment. It actually says right down here on this part, it says the Hickok Electrical Instrument Company of Cleveland, Ohio. But the real giveaway as to what this is on the back. On the back, we have a label that's identifying this as a Hickok DMS 3200 mainframe. All right, so mainframe's computer, right? So is this thing a computer? No. DMS stands for Digital Measuring System. This is actually an idea that Hickok came out with back in the 60s. In which they figured that they would make a system where you could buy this one piece of equipment and have it on your bench, and then there we go, you buy these modules, okay, and you slide in the appropriate module for the test that you want to do. So the module that happened to be in here is the DP200 capacitance testing module. And then they also made the DP170, which was the resistance module, which is an ohm meter. And they made a DP150, which was a frequency counter, good to 1 megacycle or megahertz. And, you know, the first thought was, well, wait a minute, you get 3 digits here. How the heck are you going to have a frequency counter or any of these other things? Well, apparently, according to what I read, this used some method of being able to sector what these tubes were displaying. The idea being that if you wanted to see just the last 3 digits in a long number for more accuracy, you could actually set it. There must have been switches on that module that would allow you to do that. So their claim in the literature is that the DP 150 frequency counter was good to 1 megahertz, and it was capable of resolution as good as a 7-digit counter because of the fact that you could do this sectoring, is what they talked about. So instead of having 7 of these tubes in here, which would make this thing much, wider, and they need a lot more power and everything going on in there, they figured out a way that, hey, we can get high resolution, allegedly, out of this thing with just 3 tubes. And then the other module that it came with was the DP100. Well, it didn't come with. Okay, I should preface that. The other module available was the DP100, which was the DC voltage module. Interestingly enough, I have not found an AC voltage module. This was primarily for laboratory work, from what the literature seemed to suggest. So apparently they didn't really think that, I guess, you needed an AC voltmeter. So you had a DC voltmeter. Now, I found a nice print ad. I actually was looking at that, and it's from 1966, which I thought was kind of neat because 1966 is the year I was born. All right, so while you guys are doing the math in your head to figure out how old I am, I'm just going to run some calculations real quick using the prices that I saw in that 1966 ad to see how much this would cost in today's money. Before I do that, I just want to show you this ad that I found real quick. And it's brand new from Hickok, the DMS 3200 digital measuring system. So this was pulled right out of a magazine or something, or a catalog page, and the seller is claiming this is from 1966. And since it's brand new, that would suggest to me that they came out with this thing in 1966. And I'm wondering whether or not it was very long-lived. I've seen modular test equipment like this before, and it never seems to. I can't recall any of the modular test equipment over the years that really stuck on, that really held on and got any traction. So there's a couple of things that are interesting about this besides the prices, which I'll get to in a moment. But one of the things I thought was kind of neat is that this is described, the highlighted features is it uses 3-digit biquinary tube readout. Biquinary or biquinary. BIQUINARY. I have never heard that term before. Plug-in flexibility, all about it. All electronic. Okay. Of course it's all electronic. What would it be other than electronic? Gas powered? But then the next one is really good. Fully transistorized. Now remember, this is 1960s technology here. This is a big deal, right? 1960s, transistors. But look what they did. 3 vacuum tubes for the readout. Is this fully transistorized? Not really. It's not really full solid state, is it? It's actually a hybrid. Modular design. Okay, that's not much different than plug-in flexibility, is it? Fully field tested. Okay. Automatic polarity indication. Actually right here, wrong polarity. So apparently if you hooked up the DC voltmeter input, I guess, incorrectly, it would warn you that you have the wrong polarity. Kind of neat. Something we take for granted today. I got my little cheapo Craftsman DVM over here. I can plug this thing into, I could hook this across a battery backwards, no problem. It'll just tell me what the voltage is in negative. It'll say negative 12 volts, right? It doesn't care. Well, back then when you hooked the meter up backwards, an analog meter, you could damage the meter. This thing, no problem. Just gonna warn you. You got the polarity backwards, switch the leads, everything's kosher. And automatic decimal point indication. Note right here, I believe these are actually lamps that actually light up to indicate where the decimal point is. Now, what I'm wondering is, I wonder whether or not this sucker is auto-ranging. Unfortunately, I don't have a voltmeter module to check and see whether or not you had to select range on it. But I'm noticing that basically as far as the capacitance goes, you do have to select picofarads, nanofarads, microfarads, or millifarads. But I'm wondering whether or not it automatically positions that decimal point. That would kind of suggest that it's sort of an auto ranging feature. I can't quite make out on this picture. It's not clear enough. I can't quite make out, but it does look like it does have a range switch on the DC voltmeter module. So, all right. So let's see how expensive this puppy was and how expensive it would be in today's doll. All right, I'm back with my calculations. You guys do yours? All right, so in 1966, this mainframe unit was listed in that catalog as $320. Now, it said in the caption that it's shown with the DP100 module, but it doesn't say the DP100 module comes with it. And down below, it clearly shows the separate price for the DP100 module as $175. So that makes me think that when you bought this, it didn't come with any modules, and that the $320 was just for the unit, this mainframe without any module in it. And in today's money, that would be $2,557. The DP100 module was $175. In today's money, $1,398. The frequency counter, the DP150, $175. $1,398 in today's money. The ohm meter module, the DP170, was $240 in 1966, which would be $1,917 in today's money. And the capacitance checker, the DP200, which is what we have right here, was also $240 in 1966 and would be $1,917 in today's money. So the 4 modules in today's money would cost $6,630. And then on top of that, it was $2,557 more dollars for the mainframe to plug them all into. So, I mean, that's over $9,000 in today's money. So, yeah, I mean, and this was a solution to be more economical than buying all these pieces of equipment separately. So I guess back then, they were probably looking at comparing it to a solid state DC voltmeter, a solid state frequency counter, and a solid state capacitance checker and ohm meter, which again, we're talking 1960s, right? The transistor era was, it's in its fledgling years, right? Well, for the most part, I guess, as far as being mainstream. Now, for giggles, let's see what happens if we try and fire this up. I'm not going to bother bringing it up on a Variac slow or anything like that, because where's the fun in that? All right. I am going to just kind of see how this is. This just kind of slides in. Geez, there's not a lot going on up here in the front. Oh, I take that back. I mean, well, I'll show you that in a minute, because we'll take a look at that, because that's kind of cool in itself. Show you what's going on solid state wise behind this this wall of tubes here. Which, oh, by the way, I wonder how much heat this thing generates and cooks those solid state components behind there. Some Allen Bradley style resistors up in the front. Kind of cool. All right, so I don't know which position is on or off for this switch. Oh yeah, I do. I could tell just by looking at it. It's most likely going to be on right there. Let me just do a quick continuity check. Yeah, so that's off. All right. So we are going to plug this in. It's got a nice cord on it. Plugged it in, and no sign of anything, which is good because the power switch is off. I have no idea how this is wired, though. I don't know if the 120 volts comes up and goes right through this switch, before it goes anywhere sometimes, you know, the power comes in and goes right to a transformer, and that the switching happens after it. Although I would think that would be unusual. Let's see. Try and flip this switch without zapping myself. All right. So we get the over range light comes on immediately, and the decimal point far to the right comes on immediately. I'm wondering if the tubes need to warm up before there's any chance of any kind of light coming out of them. Well, I'm thinking, I don't think we're that lucky. I think there's no light whatsoever. Well, that's interesting. The range switch actually moves the decimal point. Uh-oh. It's almost like some sort of a counter. I don't know if you can hear that or not. It's in the microfarad and millifarad. Oh, look at this! It's lighting up. Oh, how cool is this? I don't know. I think it's cool. It shows 800 and, well, it's actually lighting multiple digits there, so I don't think that's right. Nothing happening here as far as these controls go. So over range with a capacitance module could just mean out of range, right? So I mean, the real hoot would be if we put a cap on this, would something happen? I think the spec said that this could measure up to 10,000 microfarad. Just so happens I have some brand new caps right here. These are 47 microfarad at 450 volt. So, let's see. So we're in the microfarad. All right, so there's 3 positions for microfarads. So that's milli. And then these 3 are all microfarad. So this must be for over 100 microfarad. And then this would be for, I guess, under 100 microfarad. And then this, I guess, would be for... Oh, so millifarads would probably be for like 0.001. You'd have to convert it. Oh, hold on. What?
Where is the turkey?
It's on a plate in the refrigerator. What? All right, pardon that interruption. Apparently somebody was supposed to put the turkey in the turkey soup. All right, so let's see. Doesn't do anything. All right, let's take this module out and just see if there's a plug on the back that needs cleaning. I don't know. What the heck? Caution. This instrument is equipped with a... Oh, interesting. This instrument is equipped with a Mercury weighted relay and cannot be operated at an angle greater than 30 degrees from the horizontal plane. This precaution applies only when operated on the 4 higher ranges. Really? Huh. Okay. So we got a big old plug on the back here. I'm just going to look at these contacts. There's a number stamped in the back here, ink stamped 01467. Remember we said that ad was from 1966 and these were new in 1966. I am guessing, I would be willing to bet that 01467 means that this is, well, it could be January 4th of 67. Just think it's interesting that happens to be that number, just close to. All right, so let's see, I clean these contacts in the screen puff. I mean, I'm not surprised that it's not working. The fact that this whole faceplate's missing, you know, indicates to me somebody was in here poking around. Why would they be poking around in here if it was working perfectly, right? Son of a gun. Look at that. See the difference? The overrange light went out and it went to all zeros, but nothing's happening. Oh! All right, so, all right, overrange. All right, so oh my goodness, look at that. 47 microfarad. That's what I put in there, 46.9. Almost like it's sampling it or something, like it's retesting every so many seconds. This is just blowing my mind that this thing works. All I had to do was clean that contact. Boy, now that really makes me wish I had the front piece that's missing here. I'd have to literally find another one of these that didn't work that I could buy for next to nothing off of like eBay, and cannibalize it for the faceplate. But what that does tell me is that all the tubes work. So I mean, that right there is already a plus. Pretty cool. .9 microfarad. Unfortunately, the battery died while I was showing the kids this thing. But yeah, the general consensus was they thought it was kind of cool. So, anyways, before I wrap this video, I did promise a look at some of the insides of this thing, and I'm not going to tear this down completely, but I figure we'll pop the lid on this capacitor module. That didn't look like that would be too hard to do. And I'll just slide this board out a little bit so you can see what kind of treasures I saw when I was looking at this thing. So if we slide this out and just kind of look at the back side, we can see there's 2 rows of integrated circuits. They are, looks like 14 pin devices, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 in each row. So we've got 18 ICs, and then we've got a whole row of transistors. And we got 2, 4, 6, 8, 10, 12, 14, 15, and then another row of 15. It looks like 30 transistors. And these transistors are probably acting as switches and driving the tubes here. And then these ICs must be converting the input from the module to some sort of well, that the heck did I say it was whatever I forgot what it was called. But anyways, I looked up that word, and apparently there's a that's a mathematical thing. But anyways, so kind of neat to see all of these discrete components like this. You know, this is old school technology here. It was probably state of the art back in the 60s. But the reality is that probably all of this could be put into one chip today with no problem. And the chip would be even smaller than this and surface mount. We've got also some sort of a semiconductor device. It looks like heat sink, strapped to a heat sink right here. So, and we got a couple of power resistors. So not much going on in this front driver section of this thing. And then up in the back, see, there's a whole, I'm not going to take that out, but there's a whole nother part right here. It has the power transformer I can see right there. And then there's the bottom of another PC board. So there's a whole nother PC board up in the top. Pop this thing open, see what's inside here. Just 2 screws, and this looks like it slides in. So, all right, so these right here, these devices right here are transistors that I haven't seen transistors like this in a long, long time. I wonder if these are germanium transistors. Majority of transistors are silicon, and but there was a time period when there were germanium transistors. I don't know why I have such a tongue twister with that, but anyways, these are all potentiometers for doing alignment. These are also unusual looking transistors, old school. Haven't seen these resistors right here. These almost look like mil spec, kind of resistors you used to see in really high end, high tolerance stuff, like the military would use. And I'm betting this right here, these two glass tubes right here, I'm betting this is that Mercury Relay. You can see two leads coming into the end of one tube over here and two leads exiting there. I wonder whether or not, yeah, so it's not like you can actually see, you don't really see anything moving in there. Yeah, that's just a complete guess on my part that this is the Mercury Relay. We got a rotary wafer switch up in the front here. Oh, hold on. We got another device here. This might be the Mercury Relay. Up here in the front, right there, whatever that is. Yeah, that's the high-speed Mercury Wedded Relay, Adams and Westlake Company. That's the Mercury Relay. So I wonder what the hell this is. What if that's like almost like a photocoupler? You know, could be that there's a sensor at one end, and yeah, I don't know. See, interestingly enough, there's actually a component right there with leads going into it, and there. So I wonder what the heck that is. I've never seen anything like that before. Bizarre. In the back here, we've got, I see 1, 2, 3, 4, looks like 5 transistors here that are, you see these white things underneath them, those are actually sockets. So these are plug-in transistors. So for some reason, they designed this so that, well, actually, now that I look at it, actually all of these over here too, these big black ones, they're all plug-in too. So this thing was made with service in mind. If you ever had to replace a transistor to repair it, there was no soldering required. There's good and bad to that. And then yet, you go over here, and these two little transistors right here that I was talking about, those little suckers there, they're soldered in. So it's like 90% of the transistors on this thing are plug and play, and then they solder in a couple. So they must have felt pretty good about these two being durable, and then these other ones all here, they wanted to make sure they could easily be replaced. And the irony is, this looks all original. There's nothing in here to indicate to me that this has been repaired. And well, and again, they're plug-in transistors, but just the fact that all the transistors apparently match, you know, they all have a very similar look to them. If it was any repairs done to this, it was probably done quite a few years ago. So if that isn't a testament to the longevity of these components, what is, right? Tell you the other thing I'm noticing looking at this is excuse me, looking at this circuit design is the absence of any large electrolytic capacitors. I'm looking at, we got an axial one right here, and we've got another one right here. So I'm looking at, what do we got? 2 electrolytics in this whole thing? I mean, that's really, all, you know, all these other ones are like, I think these might be like tantalum dipped style capacitors. Very robust design. And then this is all, I mean, this is all aluminum, the way it's made, you know, it's that channel type of aluminum, so that you can just take 2 screws out and slide this cover right out. Very cool. All right. So in the next video, I'm going to show the final piece of vintage equipment that I scored from this haul. And again, my intention wasn't to buy this or that next piece of equipment I'm going to showcase. I went there just for that transistor checker, and I came away with 3 cream puffs. And so far, I mean, I don't really have a practical use for this, but so far I'm 2 for 2. And quite frankly, if this had the original front faceplate still on it, I might keep this on my workbench just for giggles. All right, I hope you guys are enjoying these videos. If you like watching videos like this on old tools and old test equipment and working on old stuff, just consider subscribing, please. Take care.